The retrocausality paradox states that an effect can occur before its cause, that the future might reach back and shape the past. This is not metaphor or mysticism, but a consequence lurking in the mathematics of quantum mechanics. In certain experiments, the behavior of particles seems to depend on measurements that have not yet been made. The arrow of time, that seemingly one-way flow from cause to effect, starts to bend. Consider the delayed choice quantum eraser. A photon passes through a slit, leaving a wave-like interference pattern. Yet when an observer later decides whether to record which path that photon took, the earlier pattern vanishes, as if the photon knew in advance how it would be measured. The decision in the present appears to rewrite what happened in the past. What looks like hindsight is actually retro-influence. Physicists call this quantum contextuality. Outcomes do not exist independently of future conditions. The universe seems to compute events not in sequence but as a whole, a four-dimensional web where causes and effects coexist in a self-consistent geometry. Time becomes less a river flowing forward than a landscape in which every point is already fixed, yet still sensitive to what we will someday choose. The unsettling implication is that the past is not a frozen record, but a dialogue with the future. What you do now may ripple backward into the initial conditions that made you possible. Every moment could be a negotiation between what has been and what will be, a kind of cosmic feedback loop where history itself is under continual revision. The cause may not precede the effect at all, but emerge from it, a universe rewriting its own beginning from the end. The retrocausality paradox moved from speculation to experiment in 1999, when physicists Yoon-Ho Kim and Marlon Scully performed the delayed choice quantum eraser. A single photon was split into two entangled halves, twins whose properties remain linked regardless of distance. One half, the signal, traveled to a detector. The other, the idler, followed a longer adjustable path, where scientists could later decide whether to erase or preserve information about which slit it had passed through. Here's the paradox. The interference pattern of the signal photon, recorded before any choice about its twin was made, depended on that later decision. When which path information was erased, interference appeared, as if the photon had behaved like a wave. When the information was preserved, the pattern vanished, as if it had behaved like a particle. The photon's earlier state conformed to a choice made after it hit the detector. Time seemed to lose its order. Physicists struggled to frame this without invoking magic. The simplest explanation is that the universe does not update events linearly. Instead, the entire experimental setup, from emission to measurement, forms one indivisible space-time structure. What looks like a photon reacting to a future choice is really a globally consistent solution of quantum probabilities across all time coordinates. The future does not change the past. It constrains it retroactively. This idea, known as the block universe interpretation, treats past, present, and future as equally real. Every measurement fixes correlations that span time symmetrically. The experiment doesn't reveal time running backward. It reveals that time may not run at all. Each outcome is already woven into a static, four-dimensional tapestry where before and after are mere illusions of human perception. The future doesn't arrive, it simply becomes visible. The block universe model transforms the retrocausality paradox from a mystery of motion into a question of geometry. In this view, time is not a sequence of flowing moments, but a dimension like space. Every event, past, present, and future, occupies a fixed coordinate in a four-dimensional structure known as space-time. The universe does not evolve, it simply is. What we experience as the passage of time is merely the movement of our consciousness across this frozen landscape. Einstein hinted at this when he wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. In relativity, two observers moving at different speeds can disagree on the order of events, yet each will be correct within their frame of reference. There is no universal now. If simultaneity itself is relative, then causality, what comes first and what follows, cannot be absolute. Time's arrow begins to blur. Within the block, all moments coexist in mutual dependence. A cause does not produce an effect. Both are aspects of the same four-dimensional pattern. Just as every point on a map exists simultaneously, every instant in time is already part of the cosmic layout. The photon that waits for a future measurement is not reacting across time. It is fulfilling the geometry that already includes that measurement. Retrocausality is simply the experience of perceiving a timeless whole from within a time-bound perspective. To grasp this is to feel a subtle shift. Reality may not unfold, but unfolding might be the way we perceive our fixed existence. Every decision you will ever make could already be inscribed somewhere along your world line. Yet your sense of freedom arises precisely because you can't see the map. The future may be as real as the past, but hidden from view by the moving edge of consciousness that we call now. Entanglement lies at the heart of retrocausality, the invisible thread that ties the past and future into one coherent pattern. When two particles become entangled, their states can no longer be described independently. Measure one, and the other's state is instantly determined, no matter how far apart they are. But in the retrocausal view, this connection is not transmitted through space. It's woven through time itself. The correlation is not a message sent faster than light. It's a structure that spans both directions of time symmetrically. Quantum equations, in fact, do not prefer the future over the past. The Schrödinger equation, the mathematical core of quantum mechanics, is time reversible. It works just as well if you replace t with t. Only when we observe a system introducing measurement and decoherence does an arrow of time seem to appear. But that arrow may not belong to the universe. It may belong to us. Entanglement reveals a cosmos that computes events both forward and backward, ensuring consistency across all possible timelines. In this symmetry, the act of measurement becomes a meeting point between two causal directions, influences flowing from the past and constraints emerging from the future. What we call observation could be the boundary condition that links them, a handshake across time. The photon does not wait for you to decide its path. It is already entangled with your future decision, both outcomes entangled in a single self-consistent whole. This view does not destroy free will, it redefines it. To act freely within a block universe is to participate in the total harmony of time, to fulfill what was always possible. You are not a puppet of fate, but a thread whose motion gives the pattern meaning. The universe does not move forward, it resonates across itself, and entanglement is the sound of time echoing in both directions. In classical physics, causes push effects forward. Strike a cue ball and the 8-ball rolls, no surprises. But in quantum mechanics, that clean directionality starts to falter. The equations that govern particles work equally well in reverse. Flip times sign, and the math still holds. The universe at its core seems indifferent to what we call before or after. Retrocausality takes that neutrality seriously. Instead of imagining the future as a blank page waiting to be written, it treats the entire story, beginning, middle, and end, as already composed. The events we see are not dictated by the past alone, but also shaped by the boundary conditions of the future. In physics, these are called final conditions, and they act like closing chords that define how the entire symphony must sound from the start. This isn't mysticism, it's symmetry. If initial conditions can influence later outcomes, then final conditions should logically do the same in reverse. A universe consistent in both directions would appear to us as if causes sometimes followed effects, but nothing truly goes backward. Instead, everything happens together, one vast computation solving itself from both ends toward the middle. What this means is startling. The future isn't waiting to happen. It's already part of the equation that made this moment possible. Every choice you make could be an echo of something that has already balanced itself across time. You don't chase destiny forward. You reveal the structure that's been holding you all along. At the center of the retrocausality paradox stands the observer, the being for whom time appears to flow. Quantum theory places this role in a peculiar position. Observation doesn't merely reveal reality, it defines it. A particle before measurement exists as a probability cloud, an unresolved spectrum of possibilities. But when measured, that uncertainty collapses into a single outcome. The enigma deepens when delayed choice experiments suggest that the act of observation can influence events that have already occurred. The observer, in this picture, becomes not a passive witness of time, but its sculptor. In the delayed choice quantum eraser, the decision to record or erase information about a photon's path seems to decide retroactively whether that photon had acted as a particle or as a wave. The choice made now rewrites what the past must have been to remain consistent. This suggests that reality doesn't crystallize until the observer completes the circuit, linking future measurement with past behavior. Consciousness in this light functions as a temporal feedback system. Each observation locks a slice of history into alignment with the entire structure of space-time. Physicist John Wheeler captured this in his participatory universe hypothesis. Observers are essential to the universe's existence, not because they create it, but because they complete it. Observation supplies the final boundary condition, the finishing touch that makes the universe self-consistent across all times. If reality is a four-dimensional whole, then consciousness may be the mechanism by which the block universe becomes self-aware, the interface where information traveling from past and future converge into one experienced now. The implications stretch beyond physics. Conscious experience could be the perceptual boundary between two opposing temporal flows, one moving forward from cause to effect, and another moving backward from effect to cause. What you call the present might be the equilibrium point where these flows meet, creating the illusion of progression. The mind doesn't simply observe time. It experiences the interference pattern of two directions of causality, collapsing the infinite into the immediate. If so, then awareness itself might be the universe's method of resolving its own paradoxes. To be conscious is to stand at the crossroads of time, where the universe continuously negotiates what has been and what will be. The observer is not separate from the experiment. The observer is the point where time's symmetry becomes visible, the still luminous moment in which past and future meet to form the present. Information is supposed to flow one way, from past to future, like data written onto the unfolding tape of time. Yet the retrocausality paradox exposes cracks in that logic. In quantum systems, information doesn't seem to wait for the arrow of time to point forward. It appears distributed across the entire experiment, sometimes arriving at its destination before its supposed origin. The puzzle is not whether information can move backward, but whether it ever truly moves at all. Quantum information theory treats the universe as a vast computation, but one that runs in both directions. Each measurement doesn't transmit a message from past to future. Instead, it resolves a network of correlations that already span both. In the delayed choice eraser, the pattern recorded in the detector seems to know whether the which path data will later be erased, yet nothing travels back in time. The information existed as a potential correlation from the start, completed only when both ends of the timeline were fixed. The result feels retroactive because we, as observers, experience the resolution sequentially. Physicists describe this as a two-time boundary formalism. The universe might be constrained not just by initial conditions, but by final ones as well. Think of a crossword puzzle. The clues above and below jointly determine the solution of each word. Likewise, the laws of physics could allow information from the future boundary to restrict what can happen in the present. In this view, time's apparent direction is an artifact of incomplete knowledge. Once both boundaries are known, causality becomes perfectly consistent, even if it appears reversed from within. Such loops don't produce paradoxes like killing your past self, because the system self-corrects. Any event that violates global consistency simply cannot occur. The timeline edits itself to preserve coherence. This is called the Novikov self-consistency principle. History cannot contradict itself, because all causes and effects, forward or backward, must fit into a single, unified narrative. Retrocausality doesn't break causation. It completes it. The deeper realization is that information might be the true substance of time, not what flows through it, but what creates its direction. When knowledge closes the loop between what will be and what has been, time becomes a dialogue, not a line. The past doesn't disappear behind you. It adjusts silently to the future that will remember it. Even if quantum mechanics allows time symmetry, our everyday world seems to resist it. We never see a shattered glass leap back together or smoke reassemble inside a match. This forward momentum, the inescapable direction from order to disorder, is defined by the second law of thermodynamics. In any closed system, entropy tends to increase. It's the law that gives time its apparent flow, the reason we remember the past but not the future. Yet if physics is truly time-symmetric, why does entropy always seem to move one way? The answer may lie in boundary conditions, not laws. The universe began in a state of extremely low entropy, a condition of astonishing order. That improbable starting point biases everything that follows. As the cosmos expands, microscopic possibilities multiply, and the arrow of time emerges statistically, not fundamentally. From the quantum level, both temporal directions are allowed, but macroscopic structures, stars, cells, memories, arise from the imbalance between them. The arrow of time, in this sense, is not written into the equations. It's written into the initial state of the universe. Retrocausality challenges this by asking, what if the final state also plays a role? If the cosmos has both a low-entropy beginning and a low-entropy end, two ordered boundaries enclosing a sea of chaos, then entropy could increase in both temporal directions, each relative to its boundary. In such a two-headed time, every local observer would still experience entropy increasing forward, even though the universe as a whole might be symmetric. The flow of time becomes a matter of perspective, not principle. This model reshapes our sense of irreversibility. Entropy doesn't forbid retrocausal influence. It hides it beneath the statistical noise of countless interactions. On the microscopic scale, time's symmetry remains perfect. On the macroscopic scale, that symmetry dissolves into apparent direction, a mirage produced by the universe's need to balance its own boundary conditions. The past feels fixed only because we inhabit one side of a grand thermodynamic mirror. The paradox, then, is that time's arrow might be an illusion born of cosmic bookkeeping. The universe may not be marching toward disorder, but oscillating between two poles of order, each giving rise to beings who believe they are moving forward. We are the witnesses of one side of time's reflection, mistaking symmetry for motion. If the laws of physics treat time symmetrically, if the future and past are equally real, what becomes of free will? In a block universe, every event is already inscribed in spacetime, from the first flicker of the Big Bang to the last photon that will ever fade. Our choices, then, appear less like acts of creation and more like coordinates we eventually discover. Retrocausality intensifies this tension. If the future can shape the past, then perhaps the very decision you're about to make has already constrained the history that led to it. Classically, freedom depends on openness, the ability for the present to unfold unpredictably. Yet in a universe where both initial and final conditions coexist, unpredictability becomes an illusion born of limited perspective. Imagine reading a novel one page at a time. The ending already exists, but its significance only emerges as you move through it. The story feels spontaneous, but only because you don't yet know how every scene connects. Likewise, your sense of decision may arise from the boundary between what's known and what's hidden, not from the breaking of causality, but from your position inside it. In physics, determinism and freedom are not opposites. They are complementary descriptions of the same structure. On the microscopic scale, quantum indeterminacy ensures multiple possible futures. On the macroscopic scale, retrocausal consistency ensures that only one of them fits the final geometry of spacetime. Free will, then, is the experience of selecting, through consciousness, the path that satisfies both temporal constraints simultaneously. You feel yourself choosing, but in truth, you are realizing the version of reality that was always internally consistent. The paradox is that this realization doesn't diminish freedom, it deepens it. To act freely in a temporally symmetric universe is not to defy causality, but to embody it. Your decisions are not forced from behind or pulled from ahead. They are the points of coherence that make time itself intelligible. The self becomes a bridge between two halves of eternity, translating timeless structure into lived experience. You are not a puppet of fate, but the awareness through which the universe completes its symmetry, the conscious thread that ties its beginning to its end. If retrocausality is real, then time itself may be less a sequence and more a structure, a closed loop where beginnings and endings are indistinguishable. Every event, every observation, every cause and effect could form part of a single self-consistent circuit that sustains its own existence. The universe would not evolve, it would resonate. What we call the flow of time might simply be consciousness moving along this circuit, illuminating one segment after another in what feels like motion. Physicists have long suspected such closure. In relativity, spacetime can curve so dramatically that world lines, the trajectories of objects through time, can wrap back onto themselves. These are called closed time-like curves, solutions permitted by Einstein's equations. They describe universes where the future literally meets the past. But such models were dismissed as paradoxical until quantum theory offered a potential resolution. In a quantum universe, events can self-consistently influence their own causes without contradiction, as long as the information remains globally coherent. The past, then, is not rewritten. It is reinterpreted by the total structure. Imagine time as a feedback system. Outputs become inputs, effects become causes, and the loop stabilizes into equilibrium. Each observation, each measurement, each decision contributes to the fine-tuning of that equilibrium, not by changing history, but by reinforcing its consistency. The loop doesn't trap us. It defines the boundaries within which reality remains possible. Retrocausality is the maintenance mechanism of this self-referential order, ensuring that every timeline fits seamlessly with the rest. In such a model, causality no longer flows but coexists. The universe ceases to be a line extending from origin to destiny and becomes a sphere of simultaneous influence where the distinction between earlier and later dissolves into geometry. To exist inside this loop is to be part of a system that eternally validates itself. The cosmos doesn't need time to persist. It persists because every part, past, present, and future, continually sustains every other. The greatest illusion may not be that time moves forward, but that it moves at all. What feels like progress is simply the rotation of awareness through an already complete design, a circuit where existence endlessly confirms itself. Every retrocausal model depends on one quiet rule. The universe never contradicts itself. This is the essence of the Novikov self-consistency principle, proposed to resolve all temporal paradoxes. It states that any event which could create a contradiction, such as preventing your own birth or changing a measurement's outcome, simply cannot occur. The laws of physics permit only those timelines that remain globally coherent, no matter how tangled local cause and effect may appear. Retrocausality, then, is not chaos, it is constraint. To see how this restores order, imagine time as a closed network of interdependent events. Each node represents a state of reality, linked both forward and backward through physical laws. When you attempt to change one node, say, an action that should alter the past, the rest of the network adjusts to absorb it, restoring consistency. The paradox doesn't explode. It resolves itself by reshaping the entire timeline. Quantum mechanics provides the language for this adjustment. Probabilities rearrange until only self-consistent outcomes remain. In this sense, the universe may function like a perfectly balanced equation, an eternal solution solving for its own stability. Retrocausal effects don't violate logic because the system is holistic. It doesn't process events in sequence, but as one simultaneous computation that spans all time. Every decision, every measurement, every cause is already aligned with the total pattern. Even apparent randomness is symmetry misunderstood from within. This principle transforms paradox into harmony. Instead of imagining time as fragile, easily broken by backward influence, it becomes elastic, capable of bending across itself without tearing. The future doesn't overwrite the past. Both emerge together, interlocked components of the same space-time design. What seems impossible, an effect shaping its cause, is simply the universe enforcing its own coherence from both directions. And here lies the quiet revelation. Paradoxes are not signs of contradiction, but signs that our linear thinking is too narrow. The retrocausality. Paradox isn't the failure of causality. It is its perfection. The moment when logic closes the circle and discovers that consistency, not chronology, is what makes reality real. At the end of the retrocausality paradox lies a stunning possibility. The universe may not have begun in the way we imagine. What if the Big Bang wasn't the first cause but the final consequence? The inevitable configuration required for reality to remain self-consistent across all time. In this view, the origin of everything might be less a creation event and more a retroactive adjustment. The universe fine-tuning its own beginning from its end. This inversion reframes everything we think we know about time. Instead of a linear story that unfolds from simplicity to complexity, we live within a self-correcting whole that maintains coherence from both directions. Every moment, from the birth of atoms to the decisions you make now, contributes to the conditions that made the past possible. The arrow of time, then, is not a road we travel. It is a perspective emerging from within a timeless system, ensuring its own existence. Retrocausality is not science fiction. It is the logic of a universe that refuses contradiction. The past is not a fossilized record. It's an active participant in the present, constantly recalibrated by what the future demands. The cosmos could be a vast feedback loop, eternally stabilizing itself through mutual causation. Each thought, each observation, each physical law might be part of this continuous negotiation, reality rewriting itself to remain true. To understand this is to glimpse an even deeper symmetry, that consciousness and cosmos are partners in time's illusion. Awareness doesn't merely watch the world unfold, it helps determine which version of that unfolding exists. You are part of the loop that keeps the universe coherent. Every act of perception is both memory and prophecy, the meeting point of what has happened and what must happen for it to make sense. In the end, retrocausality dissolves the line between origin and outcome. The universe is not a film projected from start to finish. It is a hologram where every frame defines every other. Causality becomes reciprocity. The future and the past hold each other in perfect balance, and within that balance, the present moment shines as the only point where eternity becomes aware of itself. Right, I still exist in the version that observes.